everyone. So today we'll be solving a very interesting problem, which is called the course schedule problem. So this problem is very popular as it is a part of the Blind 75 list on Leetcode, as well as it has appeared in various Google interviews as well. So let's dive deep into the question. So the question says there are a total of num courses. Courses you have to take labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites ith value is equal to AIBI indicates that you must take courses BI first if you want to take the course AI. For example, the pair 0, 1 indicates that you need to take the course 0. You have to first take the course 1. Return true if you can finish all courses, otherwise you have to return false. So we can imagine this question in a way that we have an entire syllabus to cover and it has a variety of courses. So in order to get to a particular course, you need to complete another course as it is a prerequisite to the other course as well. So we have to complete all the courses this way. If we are not able to complete all the courses, then we have to return false as our syllabus won't be completed. So this is the entire problem in a short summary. So looking at the example here, we have the number of courses to be 2. We have the prerequisites 1, comma 0, and the output here is true, which is understandable because we have 0 here and there is no prerequisite to complete 0. So we can easily complete the course 0 and then we'll go to course 1 and we'll complete the course 1 as well because its prerequisite has already been completed. So now looking at this question, the first brute force solution I can think of is taking and doing all the courses in a particular order so that we can, you know, complete and satisfy all the prerequisites as well. So this will challenge us in a way that we have to take in all particular orders, we have to consider every possible order to go solve this problem, which will lead to exponential time complexity. As if we scale this to, let's say, hundreds and thousands of courses, then it is very inefficient as a solution. So thinking along those lines, let's think of a solution which is more efficient and preferably in linear time complexity. So before jumping into the solution, let's also look at the example 2 where we have a false scenario. So let's see. Let's try and visualize this problem as a graph. So now why I'm taking this problem as a graph is that we have a set of relationship to show. Like we can take these courses as nodes of the graph and as the prerequisite can define the relationship between two nodes. So the prerequisite can act as the directed edge of the graph. So both the nodes I can sketch here 0 and 1. And since 0 is according to this particular example 2, we have 0 as a prerequisite of 1. So a directed edge will go from 0 to 1. But at the same time, we have another directed edge going from 1 to 0 as well. So we'll draw that from 0 to 1 as well because 1 is also the prerequisite of 0. So here we can see that whenever we are trying to take up the course 1, whenever we're trying to take up course 1, it is asking us to take course 0 and complete course 0 first because it is the prerequisite. But 0 is again sending us back to complete 1. So this way we are stuck in an endless loop. So this goes on and on and we're not able to complete any of the courses. So this is where a false condition occurs. So this entire complex problem of having a course schedule is now narrowed down into a simple problem, a fundamental problem of graph, where we have to just detect cycles in a particular graph. So now let's approach the problem in along those lines only. Now I have another example here where we have the num courses as 4 and a prerequisite array where we have 0 as a prerequisite of 1 and 0 again as a prerequisite of 2, 1 again as a prerequisite of 3 and 2 as a prerequisite of 3. So I've already drawn this particular graph which indicates this relationship. So 0 is basically the prerequisite of 1 as indicated here. 2 is also the prerequisite sorry, 0 is also the prerequisite of 2 as well here. And 3 has two prerequisites, which are 2 and 1. So how we can basically solve the problem is in the most efficient manner is creating a hash map where we can store these nodes as keys and the value will be a list or basically an array of all the prerequisites that particular node has. So this way we can keep on performing DFS, which is a traversal algorithm of graph on each node, and keep processing the prerequisites recursively by and ensuring that all the prerequisites are satisfied, and then only we are moving to the node to complete that particular course. So this is how I think of this problem. And to detect the path, we can have a visited set. We can keep adding all the nodes of this graph to that particular set. And whenever we see that a node already exists in the visited set, then and there we can return false because we detect a cycle. So now let's dry run the solution here. So we'll create a pre-map here. Here we will map the nodes with their prerequisites. There are no such prerequisites, so we'll keep it empty. Then 1 has a prerequisite as 0, so we'll add 0 here. Then next node will be 2. It also has 0 as a prerequisite, so we'll add 0 here. 3 has 1 and 2 as a prerequisite, so we'll add that as well. And that's how we complete the pre-map. So now we have all the nodes mapped to their prerequisites. So now how we will make sure that a course can be completed is by basically seeing if the prerequisite map is prerequisite array is empty. So if the zero is mapped to an empty list, that means that there are no prerequisites required to be completed before completing the course 0. So this can easily be completed. So I'll just mark it as completed. Moving on, when we also, meanwhile, we are visiting 0, we need to add it to the our visited set as well. So here, let's assume it to be a set. So we have 0 here, since we have visited 0 already. Then the next we move to is 1. Then we have the prerequisite as 0, but 0 is already completed, so we can remove 0 from this prerequisite array. Now the prerequisite array is empty, so we can simply complete this as well and add it to our visited set. Moving on to 2, 0 is again completed, so this course can also be completed. So we'll complete this as well since it is now mapped to an empty array, and we will also add it to the visited set. Let me add it here. Then we have 3. We have both 1 and 2 completed. So we can also complete 3 now, and we can add it to the visited set. As we can see that all the courses are now completed, and we never encountered any repetitions in the visited set while we were visiting the nodes. So we can be sure that this is a true scenario where all the courses can be completed without any cycle detection. And here in this case, in this approach, we visited every node and every prerequisite path only once. So the time complexity of this particular solution will be big O of n, which are the nodes, plus prerequisites. I've labeled the num courses as n and p as the prerequisites. So it will be n plus p, or which can be largely said to be v plus e, where v are the vertices and e's are the edges of the graph. And also, we are only using the visited set as the extra space, so we can add it here. We can call it O of v as the time is the space complexity. So this is the entire approach of the solution that we are going to follow. So now let me skip to the code. So as we can see here, we have already, as mentioned earlier, we have created this particular pre-map, which will keep a track of all the nodes and the prerequisites, and also will help in the initialization of the graph. We have the visiting set here, which is the current path we are dealing with. And then we also have this pre-map where we are initializing the graph, and each course is initially has no prerequisites as we are mapping them to an empty list. And then we have the the construction of the graph where we are adding the prerequisites to the values here. And then moving on, we are actually performing DFS to for every course and making sure that there no cycles exist. If the cycle exists, then immediately returns false and the loop ends. But if not, if no cycles is detected, it is possible to finish all courses, then we return true. We also have a helper DFS function here where we are first checking that if the visiting count of the current course is zero, if it is one, then we return false. If not, then we continue. So basically, this helps us to check that we are not visiting a node twice. And then if the the course value of the premap is empty, which means that it has an empty prerequisite list, and it returns true. That means it is already processed. And then we also mark the current course to be being visited in the current DFS path. And we then recursively also visit all the prerequisites for this course. And because it is important to make sure that all the prerequisites are completed before moving to the next course. And if any cycle is detected, again we return false immediately. After visiting, we remove the course from the current part of the DFS once it is processed, and we also clear the prerequisites to make this course as completed, as I showed you in the approach sketching part as well. And we return true after all the proceedings is done and every prerequisite is satisfied. So what we understood from this entire problem was this problem actually boiled down to a fundamental concept of graph, which is detecting cycles in a graph. So we should take back from this problem that whenever a huge company like Google tests us, they want to test our fundamentals, like how actively and how proactively we can actually apply our fundamentals to any question. So we should approach any problem in this particular way and try to break complex problems into shorter fundamental solutions. Thank you.